And freshman name? Upper one. Oh, sorry. Right.
10.375. Okay, so the mean is going to be 10.4.
Wait, Stella, were you here freshman year? No. Where were you?
You say you're from Atlanta? Oh, that's still cool. Still cool.
Our nation's capital.
Originally, I'm from here. Our nation's capital?
Yes.
Our nation. Did you miss it?
Yes. I don't think
It's just different. Yeah.
All right, so advantages of the mean. The mean is relatively relatable. So what that means reliable.
Relatable.
Yeah, the mean is
Like for
relatable.
more relatable team.
It's reliable. A, the mean is gonna be a pretty good indication of the central, right? The middle.
Oh.
Unless there's some crazy
See, as soon as I start the screencast recording, that's when you guys start talking about like Sacramento and hitting each other. And
I didn't even realize you started the screen.
surprise! There you go. I'm not missing anything.
Wait, can we say hi to everybody?
No.
1, 2, 3.
4, 5, 6.
All right. So means of samples drawn from the same population don't vary as much as other measures of center. So if I would have had like a couple freshmen, a couple sophomores, a couple juniors, as well as you guys in here, like this would still be a sample, maybe like 20 kids. But then it's like pretty much spread across the different ages, so that way it would be pretty reliable. All right, disadvantages, it's sensitive to every data value. One extreme value can affect it dramatically. It's not a resistant measure of change. So what this means is, imagine Shaquille O'Neal walked up, sat down
It's a
here.
big guy.
And he sat next to Jasmine.
Thank you.
Sure, sat next to Jasmine. So
Jasmine is the shortest person in this one.
So he would be an outlier because he's literally 7 foot tall. Our average would be skewed. Our mean would be skewed heavily.
That's like whenever we want you.
Because how tall? Ready? How tall are you? Rapid fire.
5 foot.
5'11".
Okay, like 5'8"-ish. So our average is probably around, I don't know, 5'6" or so, right? Shaquille O'Neal walks in, our average is going to jump to like 5'11", which is
What? They would go way more than that.
whatever.
Kid's a monster.
He's not
He's
kid.
9'4".
Goodbye.
10'12".
No,
Bye.
he's not.
Bye.
Is
Okay.
he?
No, no.
Like
20
like
something.
Anyway, so if you have some outliers, aka things that are really, really small and really, really big outside are like, you know, our core central little group, it's gonna throw off the mean. So the median's another way to figure out like the average, right? The middle, what's right in the middle of my values. Median, if you arrange them from biggest to smallest or smallest to biggest, it's literally the one that's right in the middle. You denote it by x tilde. Literally, you have the NA on top. You have the little like,
that's in Spanish.
yep, x tilde. So this is the median. To find the median, arrange them in order. If you have an odd number of terms, it's the one exact middle. If you have an even number of terms, you take the two that's in the exact middle, average them. That's it.
Oh, is that when you do this? Slash.
You add them up and divide by 2.
Sure.
Yeah.
Okay.
When you're crossing out the
So I need to write these in order. So let's see. Find the median. So I have 1, 5. Okay, 5, 1, 7,
No, there's
9.
another 5.
Dang it.
It's
Okay.
okay. Oh, that was smart.
Yeah,
I wouldn't
thanks.
have done that,
19,
though.
23.
Can't think on my feet like that.
Wonderful. Okay, how many things do we have here? How many data points? How many
1, 2,
pieces
3,
of data?
5, 6, 7.
2, 3, 4, 5, 6, 7. Really? Only 7? Did I miss one? I missed one. I missed 14. Oh my gosh.
No, there's 7.
1, 2, 3, 4, 5, 6, 7, 8. Okay, so there's 8. So there's a even number. I have to go to the middle. These are the middle two. I add them together.
Divide by 2. You will receive the number 8 as your answer. 8.0.
8
Added S.
x tilde equals 8.
Oh, you have to rewrite it in like
Yeah, man.
ascending order.
Or descending. Either you put it in least to common. No. Because I still have 9 and 7 in the middle.
Also, why is it a squiggly? Shouldn't it be a dot Or is that your dash? I don't know.
No, this is x tilde. It's a tilde.
Oh, sorry, I didn't know.
Because medium gets the
Hilda.
squiggle.
It's a tilde.
Until
Okay, so find the median of the following set of numbers. Okay,
Wait,
so
what is tilde? Oh, when you use the median? Sorry. Okay, I'm behind in understanding today.
6, oops, 38. Okay, so I've numbered them lowest to highest. The exact middle. Yeah, take it. The exact middle is 25, so x tilde is going to be 25. The median, the thing that's right in the middle, is 25. Excellent day. Okay. Now, what does mode mean?
Oh, mode is the most group.
Yeah, the value that occurs with the greatest frequency, aka repeated the most. Repeated the most. Mode is repeated the most. Okay. Data sets can have more than one mode, though. They can be bimodal, which means two modes. How old are you?
I'm 18 years old.
17, 18.
Okay, let's say, okay, so right now our mode is 18.
Yeah.
That's the one that's repeated most. Imagine that I had some of the sophomores here. So I had 18, 17, 18, 18, 17, 17. I have two modes. I have 17 and 18 because they both repeated 3 times. So that would be bimodal. Literally, you have 2 modes. Multimodal,
Wait, do they
more
have
than
to be
2.
the exact same?
They have to repeat the exact same number of
Okay,
times.
okay.
No mode, no value is repeated. Okay, so let's check it out here. Example 4a. 1.10 is repeated. That's the only number that's repeated twice. That is my mode.
So it's bimodal.
Nope, that's it. I only have one mode. Because guess what? On the bottom one, 27 is repeated 3 times, 55 is repeated 3 times, 88 is only repeated twice. This is bimodal because it literally means I have 2 modes. I have 27 and 55. Exactly, versus the bottom one. If I would have had another 88, it would have been trimodal because it would have 3 modes that repeat the same amount of times. Alright, the bottom one, guess what?
No mode.
No mode. No repeating. Okay. Cool. Flying through. So this is the meat of our hold on. This is not quite the meat of our session.
Wait, wait.
Blah blah blah. Okay.
Wait for homework. It says part 1, section 0.8, handout 1.
Yep. I haven't handed out yet. Because I want you working on it while I teach you.
But we don't have like a.
Assignment from the book, correct?
No, we don't.
Correct. It's the handout that I haven't given to you yet.
So,
I'm giving
is it hard?
It's not hard. Give it to you at the end. That way you don't work on it during class.
I would never do that.
Yeah.
That'd be silly.
Look me in my eyes and say that.
It's called homework, not classwork.
Whatever.
Thanks, Jeremy.
You're welcome.
Who's the screencast for? If
Adam.
They're gonna learn it.
Adam testing.
Stupid Adam.
You know, at the beginning, I was like, Adam, hello, you're listening to this.
You are currently playing baseball.
He forgot.
Adam.
You guys forgot he
I'm
existed?
just guessing you guys are gonna lose anyways, so I'm not gonna answer.
Whoa.
Oh.
I'm kidding.
Give him my full,
That's a terrible thing to say.
give him my full okay to, okay. Oh my gosh. How long has it been?
Yeah. 15,
Let's see, so Adam is at baseball. Let's turn 5th.
Why are you watching the screencasts and not knowing where you skip? You just keep getting quiet and talking to your friends, but you actually don't know when the lesson is to listen to this.
Yep. This is why I do not like doing this. And I try to make the screencast like so it's short. Okay, so let's keep going. So range. What does range say? Jeremy, read out loud.
The difference between the maximum data value and the minimum data value.
So the greatest
Range
and the
equals
least.
maximum value minus minimum value.
The difference between the highest and
It is very sensitive
Oh my god.
to extreme values. So it's not as useful. Because imagine these are the test scores. Ready? 91, 94, 90, 92, 97, 27, 90,
Oh, okay.
93.
27.
Like, oh wait, most of the scores are all in the like 90s, but then the one outlier like threw off the range because it's always max minus min. Okay,
Wait, can I ask a question?
yes.
Do you have to report every test to the department then? The grades of every test?
She has full access to all of my haiku,
Oh, okay.
so she sees.
I was wondering if it's like that for every test.
All the department chairs have full access to
Oh.
all of
Must be
haikus.
nice to be the department chair.
So sometimes like I'll get a comment like, "Oh, she's like, you have a lot of stuff up there. Good job." I was like, "Oh, what? You looked?" It's fine.
What do you mean you have a lot of stuff?
Yeah, like I give you guys a lot of resources.
Oh.
Okay. Measures of variation. All right, test scores for a particular chapter of algebra are listed below. Find the range. What's the maximum score? 97. Minimum score 70. So max minus min gives me a range of 27. Okay, cool. But like it's not that useful because all it takes is one outlier and then it's thrown off.
Also, that number doesn't really tell you anything.
It tells you like, okay, everyone was within 27 points of each other. Versus if I said everyone was within 5 points, whoa, that's crazy.
But everyone isn't within.
No, they're not.
Yeah, not bad.
Because I look at my range, if all the test scores were like within 5 points of each other and the average is like a 97, I mean, okay, either it was a too easy a test or like people worked really hard, you know? Do you need your phone out right now? Okay. Just put it away. Okay.
You want me to put it in my backpack?
Yeah. Standard deviation, the measure of how much values in a set differ from the mean. Standard deviation, how they deviate from the mean. So if everyone's test scores, within 5 points of each other, it's going to be a small standard deviation because they don't really deviate from each other. So it's denoted by this lowercase sigma. So that is a lowercase sigma. It's an average deviation of values from the mean that's calculated by using the following formula. So the sample standard deviation is the square root of the sum of every single point subtracting the mean squared over n minus 1. WTF, right? This is rough. Which is why I have an example I'm going to lead you through step by step. But just some important things to know before we do that. Let's see. So this is sum. This x is any data value, whatever data value we're interested in. The x with the bar is the mean. And then this n is literally the number of data values. Okay, so we're going to break this down step by step. First thing we're going to do, find the mean. And then I'm going to go through, take every single value, subtract the mean from it. Then I'm going to take every single one of those values, square it. And then I'm going to add them all together. I'm going to sum them. And then I'll take that sum and divide by number of data values minus 1. And then at the end, take the square root. So that's a lot of work for one little pesky number. So I'll show you how to do it by hand. And then I'll show you the glorious part of your calculator that will do it for you. Okay, so standard deviation is a measure of variation from all values of the mean. It is usually positive. It can also be 0. Standard deviation is never negative. It's kind of like absolute value, right? Absolute value is how far you are from 0. Standard deviation is how far away you are from the mean. So you can be 5 below, 5 above, but you're always just like 5. It's always positive, never negative. The larger values of sigma indicate greater amounts of variation. So we have a lowercase sigma and a capital sigma here. That might be a little confusing. So if we have lots of outliers, lots of numbers are like, either really big or really small, not close to where most of the numbers are. Sigma, the mean, the mean can also change, but mostly like the standard deviation is going to be blown out of control. And the units of standard deviation are always the same as the original data values. Okay, so the first part of the procedure, here's the formula. So this is like, this should not say S. It should say, should it say S? Well, I'm trying to find sigma, so yeah. Should have like it's almost like a sideways 6. That's the sigma, lowercase sigma. And then it looks like almost like an E That's the capital sigma. They mean two different things. All right, so I have an example, 2, 8, 10, 12, 14. So that's 1, 2, 3, 4, 5. N equals 5, so it's 5 total items. First step, first box down, step 1. Compute the mean. How do I find the mean, Liad? What do I do? Exactly, I'm going to add them all and divide by 5, the number, that's the number of items I have. 2 plus 8 plus 10 plus 12 plus 14, all divided by 5. 2 plus 8 is 10, plus 10 is 20, 32, 46, divided by 5, 9.2. Cool, step 1, done. I found the mean. Step 2, subtract the mean from each individual value. Subtract the mean from each individual value. That way I have x minus x bar. Okay. What? It is a lot. But process gets a little faster and then turns out your calculator will do it for you. Okay. So I have
Step 2, subtract.
2 minus 9.2 is negative 7.2. 8 minus 9.2 is negative 1.2. 10 minus 9.2, 0.8. I'm going through every single data point and subtracting my mean. Yeah. 4.8. Okay, cool. Step 2 done. Step 3. Square each of the deviations obtained in step 2. AKA, I'm going to take these 5 numbers and square them. So step 3 is I'm going to take all of these and square them. So negative 7.2 squared. Huh? Step 3, sorry. I'll write it below. Alright, so this is step 3. Square each of them. So now I'm going to square the values I found here.
Wait, you're telling me that your calculator would do this entire thing in one step?
Uh-huh.
It's
It's pretty rad. The Inspire especially. Yeah. So
Hold on for Norris.
if you
I
turn
have the Inspire.
if you turn the page, it tells you how. For your 84.
Girl.
And then I'm gonna watch, because the reason I put the directions for the Inspire on there is it's 2 steps.
The Inspired is 2 steps.
Uh-huh.
Oh, I've seen how you do it. I've seen it.
Yep, let's do this. Okay. 7.2 negative 7.2 squared is 51.84. Negative 1.2 squared, because this is how we used to have to do it. Yeah. Whatever.
What are the data values for LI? L1.
Oh, you didn't have this? You didn't have a calculator that did this for you? No way.
No, I did, because
Yeah.
I had the 84. But,
Wait, could you bring the 84 into that with you?
Yeah.
You just can't bring in the Inspired for you.
you can. You
No
can use the
way.
Inspire.
For
Yeah.
what?
You just can't use the CAS. You
The
can
one
use...
that we own?
No.
The one you own, you can. That's why we have you guys having that one, not the CAS.
Why do I feel like you can't?
No, you can't.
I read that you can. I didn't bring
Maybe it's the CIS.
No, you can. It's just.
Isn't the CIS like a little computer?
Yeah, it's the...
Can I buy that?
That's why they don't have it QWERTY. That's why it's not in QWERTY.
Is it?
That's the reason why the keyboard's not in QWERTY, because that way it can be used on.
Well, so that's the addition.
What
But
is
the special
What is
excep-
QWERTY?
exception is-
I don't know. I heard QWERTY.
QWERTY. Keyboard. QWERTY.
So
QWERTY.
Oh,
QWERTY. The normal keyboard.
Yeah.
That's why if you look at your calculator, your Inspire, it's like A, B, C, D, blah, blah, blah.
Why?
Because if it was in QWERTY, they wouldn't allow it.
Why?
Because you're used to. They want you to struggle finding the letters.
People spell-
That way you can't go. Yeah. Well, I don't know. Whatever. I didn't make up the rules. Why do you hate on me? Whatever.
Yeah, but this one's
Alright.
like A, B, C, D, E, F, G, but you
Huh?
can't just click it. You have to do
Right.
in order.
Right. So you have to.
But now I'm used to it. Like,
Whatever.
No, I'm
Okay.
not. I
Okay.
look for it all the time.
Step 4. Add all the squares obtained from step 3. The result is this section. So notice how we're working our way from inside out.
Yeah.
Like I'm about to finish the whole top of this square root.
I'm gonna do this first. Your instructions. It's
So I'm going to add everything up. So if I sum it up, it's equal to 84.4.
I'd like an emotional attachment.
Step 5, divide the total from step 4 by the number n minus 1, which is 1 less than the number of sample values present.
So 4.
Yep, so I'm going to take 84.4, divide by 4,
Why do you
21.1.
subtract 1?
What? Because it's n minus 1, not n.
But why is that?
Because it is.
That is the way it is. I love this.
We're done.
No, not quite.
Well, almost.
Super close. Okay, find the square root of the result, step 5. So, square root of 21.1 is going to be 4.6. So, the standard deviation is 4.6. What this means is each data value is an average of 4.6 units away from 9.2.
Can I ask a question?
Great.
Yeah.
On the test, are we going to be using our calculators in this process?
Yeah, so can you teach me now? I'm not calculating.
Wait, she answered my question.
Hold on. Let me finish writing this.
I'm gonna have a calculator and a non-calculator, and one gonna do it, and another one gives you harder ones and you can do it calculator.
Oh.
Right? What would you do that?
It's like you know the way, I think. Okay.
I know you wanna keep it long.
Huh?
I know you wanna keep it long.
It's predictable. You can guess what it's gonna be like. I have a practice quiz for you guys, so.
Already?
Well, I mean, I have the whole unit, so that way I
Quiz
know,
on Friday.
I know what,
Is
like,
it quiz actually on Friday?
yeah.
Yeah.
That way I know my goal.
How many sections? Wait, are all these kids gonna be back on Monday or what?
Yeah.
No, don't they get Monday off? Oh, no, they get Friday off. Oh, they don't have,
Oh,
no.
that's such a short period.
Yeah.
Oh, but what about sophomores?
They're not done. Yeah, but
Alright, let's keep going.
It's
Alright,
tight stuff.
so he is a junior.
Also, how do you spell his
Fine. TY. Alright, find the standard deviation of all the sample values.
Oh, yeah.
We did TUI,
No.
THI,
Alright, so this one we can go a little faster. Guess what? There are a total of
TIE.
5. There are a total of 5. There are a total of 5. If I do step 1, the average of all these, 5 plus 9 is 14. 14 plus 6 is 20. 20 plus 3 is 23. 23 plus 7 is 30. Divide by 5 is 6 total things. Number 2, step 2, I'm going to take each value minus the average. So I'm going to take 5 minus 6, 9 minus 6, 6 minus 6, 3 minus 6, 7 minus 6. No. No.
Wait, I'm gonna be honest, I don't understand what we're finding here. What is this?
Standard deviation. It's the average distance away each value is. So the previous problem, each data value was an average of 4.6 away from the mean. Standard deviation is how far away you are from the mean. The average amount you are away from the mean.
Oh my god, they always start ask questions about this on the SAT.
Yep.
Oh, and it was probably on the calculator section. I didn't know how to use my calculator. So I probably just. Oh, you know what they did? They were like find the mean and then find the standard deviation. I always knew how to find the mean, and I never knew how to find the standard
I
deviation.
never even knew.
Yeah, exactly. And then
So what about the
19091. What?
What do you do once you square them?
After I square them all, now I'm going to sum up all of the.
Can you add them?
Yeah.
Square.
Yep, add up all the squares. 1 plus 9 is 10. So it's going to be 20. Fifth step, I'm divide by n minus 1. So since n minus 1 is 4, 20 over 4 is 5. And then sixth step, guess what?
Wait, what the heck is the 5 step?
Square root 5. So if you look up above, step 5 is dividing the total from the sum, divide by the number of sample values present. Step 6 is taking the square root. So it's 2.2. So
You just took all of the
step
squares
4 is
and
adding up
added
all the
them
squares you obtained,
oh,
literally summing them up.
step 5 is subtraction.
Step 5 is taking that number you found, dividing by the n minus 1. Dividing by, well, 4, because n was 5. Number of values were 5.
And now you take the square root of it.
And then you take the square root.
It's really not that bad.
No.
So this means every single value, 5, 9, 6, 3, 7, we're an average of 2.2 units away from the average, which was 6. Huh?
I don't understand that.
So, okay, if I look how far away each thing was away from my average, my mean was 6, right? So if I look at every single data value, 5, 5's only 1 away, 9 is 3 away, 6 is 0 away, 3 is 3 away, 7 is 1 away from the mean. So the average amount away from the mean is your standard deviation. It is 2.2. That's the average amount we are away.
1, 2, 3, 4, 5, 6.
All right, so I'm going to show you this last one on the calculator.
Oh yeah? Okay, great.
Okay.
Stop. You're like the meme that I sent you.
Can you stop doing your
Stop doing
name
that.
pencil and trying to put it?
Oh.
It's on his toes.
I know.
Okay.
No,
So we are at the home screen. We're at the home screen. Are you ready for this? You're at the home screen? Are we at the home screen?
I have 84, so.
I took it out after the test.
All right. Well, I'll show you.
It's not yours.
Wait, what?
Exactly.
Sorry.
No, I don't have any phone. I have
Okay.
the 84. I also have the 84.
I
Click.
got the link.
List in spreadsheets. Click it. Hey, check it out. Look, it's a spreadsheet. Let me enter in all my values. Correct, because I know some of you have 84, and it takes 2 seconds to do it on the Inspire, so I was just going to show people. Alright, so let's put in our values 2.3. Actually, let's do the old ones. Let's do the past one that we just did to prove that it works, okay? Alright, 5, 9, 6, 3, 7, and I pushed like enter after I put it in, so now I'm on a blank piece. We okay so far? So go over, click menu, go down to statistics, statistics calculations, one variable statistics. We okay so far? It's just a board. Push it. It says, oh, how many lists do you have? I only have 1 because I just wrote the first column. And it's like, oh, hey, where's your list? Yep, it's in the A column. That's it. So push OK and check it out. What did we say the standard deviation was? 2.2.
Ah.
That's it. So look, we have 5 items. The min was 3. So you click menu. So you clicked menu. You go to statistics, statistic calculations, one variable statistics, enter. That's it. It's even faster than the 84. So
84 is actually so much stuff. Right on it.
that's it. Yes.
So in statistics, it start calculations.
What? I'm not in. Oh, statistics, stat calculations, one variable statistics.
How many problems are on there?
Not too bad. Not too many.
Could we do it?
Let's see. So I go through.
I'm doing it right now.
Go through here. I think.
We have the last 20 minutes to do.
Yeah.
Wait, where is it? Is it in the back?
No.
He's giving-
Oh. Okay, cool.
We're gonna finish 0.8 because I messed up. There actually should only be. It should just be 2 lessons for 0.8. Right, and